Okay, good evening all. On a Saturday evening and the fourth talk, so I'll try to keep it as quick as possible. So, how many of you know the term monolith? Just trying to understand the audience and then so that I can continue quickly from. Okay, and how many of you are scared about this term monolith? Okay, so then the rest of us who are working on monolith, but you're not scared, then hopefully it doesn't come and you are working on good. So not every developer get to work on a project which is greenfield, or you're starting on a very new tech stack and everything is going well over there. There'll be many projects where it's already there from many years, and it has already come to a state where making even a smaller change over there will take a lot of time. So why it takes a lot of time? There can be multiple factors over there. One, the code. Sorry. So just to come on the definition side, okay, what is a monolith? It can be a legacy application, one single application which is doing a lot of things over there. So you're not actually worried about any responsibility given over there. Like, okay, it's basically one app. Whatever we are discussing about the single page application in React, right? Even at one day, it can become a monolith over there because it's going to be doing too many things. And then it will be tightly coupled in some cases where you have a set of dependent modules where you're integrating with them, and you need to stick to them because you'll not be able to scale to a different platform or connect to a different provider. So those kind of extensibility will be very difficult to achieve over there, and you'll be kind of coupled in one particular ecosystem. So this is a bit scary in places where you have application is like already in a full-fledged. So I will take an example, like there are a lot of e-commerce applications which were designed 8 years back, 10 years back, and then at some point, even 4 or 5 years back, they would have moved to some other providers. They'll give an end-to-end solution. You have an OMS, you have a full content management system, everything built in over there. They will only give up payments providers, and it's all integrated with a set of solutions. Now, in the current situation where you have a lot of different players in the market, you need to have the flexibility to quickly change every day and try to adapt. So if today you want to have a, let's say your website is having just a username login right now, username password. Tomorrow you want to introduce Google login, Apple login, and something else come up every day, even OTP based login. So every day you want to change very quickly. And in a monolith, that is not easy to do. So reasons, there can be many. I said it's difficult to extend to a different providers. Then it can be on the actual code. People who wrote the code may not be available in the organization, and the code may not be properly written over there. I use the word spaghetti code. Like sometimes what happens is you have an application where making one small change in a code you'll be like, okay, praying, today I'm going to make this change, push into production. Should I push it to production on a Friday evening? Like you will be in that particular things. So, I mean, it's a reality. It's not just about some memes coming around, but it usually happens. Like there will be many such spaghetti codes over there. And even when you make one small change, you have to run entire test suite to make sure everything is going smooth, even though the pipelines will be such that you cannot just test a module which you have made change right now. Even if you want to release something, the entire suite need to be going over there. If you have seen Jitu Bhaiya, he will run a test, he'll go for a coffee half an hour and come back in the TVF pictures. I mean, these are all not just in the shows, it happens in reality as well. So there's a testing complexity as well. So if something breaks from your change, it becomes very difficult to understand. Did you actually break something, or because of your change, something else broke somewhere? So you should have a proper test of, those long automation test suites, everything should be there. And then any change you make, it will take a lot of time to go to production. So because 10 different teams will be working on the same code base, you should always have a release plan. So you will have a release plan for the next 4 months. You are starting working on some things, and everybody give their builds to some single, let's say, release coordinator, and then they create a package, then they release. If something goes wrong, and then again it's a very big cycle to make some change and push over there. And obviously the scalability and the performance. So if there is a section of your application which is right now taking a lot of requests, and if you want to scale that portion, it's very difficult to do that. You will still need to scale the entire architecture. Or let's say you have um, I don't know whether the rippling part, I'll take some Flipkart or something. If Flipkart was a monolith, can you just scale up 10 different instances of everything running over there and then have to adjust to the load just for one particular peak time or something? You can still do that, so setting some auto scale, but on a monolith application, it is like scary scenario to do over there. And then the performance wise, if you want to achieve, like, there are a lot of nowadays in the millions of requests in a day. We'll talk in terms of number of requests you need to serve in per second and all, right? Those again change from one application to another application. So you should concentrate on, okay, what part of my application is required with a higher performance. Just in the previous talk, I guess I forgot the name. So he was talking about server side and the server side pages ingestion, and then the difference in client side pages, right? Again, you can actually decide what you want to do if it's not a monolith, and you can, based on what pages require optimization and all, you can actually change. So all these problems are in the monolith, but does that mean any new applications which we are building nowadays, is it going to be safe enough and kind of not prone to any of these things which we listed? Initially, yes, maybe when we start, but over a period of time, we keep adding features on top of that, and then we need to have a lot of tests to cover up. I mean, obviously test is required, and even if you start the test driven development, it will be there from the beginning, but the kind of tests which need to run for all the different scenarios in your application, and then it comes to the performance part over there, whether your bundle is becoming more and how do you want to split that. All these things will start coming into picture at some point in your application if you don't think about your architecture from the beginning. So do I also, I had one question, like, everything is bad? I will also say it's not always monoliths are bad. When they actually build that particular part, that was the best tool available at that particular point. So we don't have to think that something which was old is bad, or whatever we are building is actually like super great or something. We should make sure what was good at that particular point, take some learnings from there, what is best available at the current scenario, and how do we adapt to that. So I'm going to take a exam. Not much demo is going to be in this particular session. So if you at any point, if you feel boring, you can start asking me questions so that we can make it more interactive. So I'll take on like a typical e-commerce scenario. Okay, so you have a page or an application like this where you always have something like a common header component. You will have a common footer component. You can go to any website, Flipkart, Amazon, or whatnot. The content usually don't change on the top, or the pattern is the same, and then the dynamic content what you have changes from one page to another. So if you're in a PDP, then it's a different way of rendering over there. If you're in a checkout page, then it's a different way of rendering over there. And each page, it has some context in what you're rendering on that particular page. So let's say if you're in a PDP, you're more concentrated in terms of to give a lot of description and all for that particular product. You may not be really interested into whether a user is logged in or not. In that particular case, you can actually do something different. If you're in a checkout page, you need a lot of context over there. Who is browsing? What's the information he has added? The customer has added to the cart. What do we want to do over there? But there might be some components which can be reused in every different places. For example, let's say you have something called a recommended products. So this recommended products is something you can actually display wherever you want. So if you're in product description, you're browsing one product, but in the bottom you can show some other recommended products based on what the current product is. So if you're in a bag, you can show different variants over there. If you're in a checkout, you can still show recommended products based on what in your cart, and then suggest, okay, this person bought a ladder, and now you can buy something else which is related to that particular product, right? So that is still an option over there, where some components you can use in a different pages, but still a context is important over there. If you want to show recommended products in a PDP, maybe a context is slightly different based on the product which you are there. If you want to show a recommended products in checkout, the context is different, and then based on that you need to show that data and render it over there. But if you just don't just think about the data, maybe in your application there should be the similar design and the UI should be similar in all the places. So if I'm seeing a tile somewhere, so let's say I'm just selling some SIM cards at the moment, and at some point I just have some basic things to render over there. I can have a SIM card rendered like this with some data in one point, but I should also make sure I have the same design pattern which is rendered in all the places wherever I go. If I keep changing from one place to another, the user will start thinking like, okay, this website is not like that UI friendly, or I'm not liking it, and then you may actually, I mean, if you can like the product, but sometimes if you are not intuitively using the website, right, you may not come back to that one if you're not liking the look and feel. So why do we need to now think about breaking the monolith, right? You need to now start, okay, how I can work on a new technology, maybe that is one. How I can improve on a particular feature which requires immediate attraction right now, which you are not able to do with, or it's taking a lot of time. And then you sometimes wants to have a good developer experience as well. Like you don't want people to join a particular project where the code is like in a really messy state. People will join, they'll start working, and then maybe they will feel like, okay, no, I want to change the project, or sometimes they may leave the company if your code is not in a good shape over there. So in all these different scenarios, you prioritize where you want to start and then how you want to improve from that particular state. So let's take something like this. So I have the body, and in the body you can have different components over there. Try to pick, I mean, there can be two different ways to split. Okay, so one, take a small piece of context, like a small context which you feel like is important at the moment, which you feel like you can immediately want to add new features. So if I want to talk about checkout, if checkout is really important to you, pick that as an initial small component, try to extract it out from your monolith, and then inject it into the application. So in this particular case, I mean, I have trying to say in two different starting points right now. So one is taking out a micro component, or starting out with a simple page, and you can build on top of that. So taking out a smaller piece means you had initially two components, and you take one and build it separately in whatever the new tech stack which you feel like doing over there, and then inject that in your old one. So a portion of it is kind of taken out from there, but there is a slight, I mean, not a issue over here, but this kind of happen in two ways. One is as a build time, and then as a runtime. So if it's a build time, like you take a component outside, publish it in your npm registry or somewhere, and then add it as a direct build time dependency, so you know where is your component coming and over there. On more on the runtime injection, have a, I mean, one of the example I'm saying is have a div or something which is kind of a placeholder for you for that component. So you can have a div for recommended products, and then your component will load and then replace that div with a set of data which you want to show over there. So this is like in your old application, maybe you had some older code, you can actually clean up all those things, move that into a new module, keep it outside, inject that, and okay, you started now refactoring a piece at a time. So you don't have to take it completely big. The look and feel can still remain the same. Your application, you're still in whatever that, let's say you have some old JSP application right now, that can still remain as it is, but inside somewhere in one particular div you can take it out and build it separately. Or the second approach which you can go is with a new page completely. So let's say a checkout as a page. The entire page you can actually remove from your existing application, and you can create a new application, maybe a single page application in this particular case, and host it outside. For your old application, let's say it navigates, as soon as you click a button checkout, it moves to /checkout. It will still do the same, but now you can replace the /checkout route into a new SPA which is hosted somewhere. And that one you can choose again whether it's a TypeScript project you want, or whether you feel it more of a client side rendering, server side rendering, whatever you want. You can choose all those things in the approach, but start with a simple. Why I say simple in this particular case, like a new page with the MVP, it will take again a lot of time to build something to match the existing functionality which is already there. The risk with breaking a monolith is you already have set of features in your production, and when you give an alternative, you need to make sure all those components are still in place. Otherwise, for the user, there is a missing functionality whenever you try out. Even if you do a A/B testing where only for a 10% of the users or a 20% of the users you want to give a new page and try out how it is going, they will clearly see the missing details over there. So if you, to avoid that, like a clear um, for them not to miss the details, right? So start with something simple. So you can still have a checkout page, but only with few functionalities which is required for them to complete the transaction. And then once that is ready, you can have multiple people now start working on the thing, and then the dependency and all you can start uh, the dependency you can start reducing now. I'll tell you, I don't know in which slide I have, but yeah, I'll reach that one. So starting in a different page, right? That can also be done parallelly as well. But why I said is start with one page in the beginning is it acts as a ground, like a base setup with all the bootstrapping code, or the where you want to have the routing, whether it is working out well with your project and all. And once that is success, you have the performance and all, everything sorted over there, you can easily extend it into all the different functionalities over there. The same with go to the injecting approach as well as the new page approach, but always start with one component and then try to extend it into multiple contexts. Now, let's say in the same approach, you replace both the components here, and then there are two different micro frontends which are injected over there. For some reason, you may still have some communication required between the two, or like changing of one may be required to update the state in the other. For example, let's say you're in a product page somewhere, you show a set of recommended products somewhere, you click add, and then your mini cart somewhere should also update with the new set of products which is available over there. So there is a like you clicking on a one component doesn't immediately make sure the other component is re-rendered over there. So in that particular case, communication between the two micro frontends will be necessary, and you can have the like the window, the global context over there, like to store some data, like you show something over there, or you can have custom events like I did something. Now it's up to the other component to fetch the data for the new state and then re-render, or if it requires to make even a new call and get the data from the server, it can still do those things over there. So making sure the communication between the micro frontends is proper is one of the key things over there. And then not just about within the components, but sometimes to get the data for that particular context also. So you may require a user session. So if a user is logged in, you may have to show different data. If a user is not logged in, you may have to show different data over there. In that case, using a session data is also really helpful. Um, Now, coming to how do we structure the micro frontends. So it can all start from very basic block and then go all the way till the page. So you can start identifying what is a small component which you feel which is easy to reuse in multiple places. You can start from there and say, okay, I need to just render a product card. So maybe you can create one component and initially start with that. Then you can have multiple kind. Okay, I have a button right now, and in my entire website, wherever I have the button, I need the same styling for the button. Then that can become a component for you. You can, if you have a picker somewhere, and that or like a drop down or something, that the styling of the drop down changes from page to page. Now, if you want to use that in a different components, again you need to make sure that's available in a single place, so that other person doesn't have to write the same logic or even worry about the styling, even a smaller details over there. So try to come with identify the components and then build a component library out of it. So in whichever the new applications which you create, you can easily take the components which you from your library and then you can build on top of that. From the previous talk, for example, I18 is a very good example for a library over there, but this is, I mean, this is more in terms of the UI components. I'm telling you, you can build a library out of that so that you can try to import and use what is already there in your design library. Have widgets. The difference between a component and a widget, in a component you pass some data and it renders. It has nothing to do any other, I mean, it doesn't have any other state or something. You fetch the data somewhere, or you know what need to be rendered, you pass it to the component and it just renders over there. In a widget, it can have some more business rules like what need to be done, or based on the data or a context, I can render myself as in a different state. So let's say you're a logged in user. Then if on the server side, they know your browsing history and all, they can actually give a different set of data to you, like when you make a API call and then you render over there. But making an API call and getting the data is also, there is some logic involved over there. And if you want to have this recommended products in the multiple places, you don't want to write the same code to fetch the data again and again, right? So if you just make that as a widget, then all the business logic is also there. And in any page, you can just plug and play that. Like you can have a set of divs, and one div will just have the recommended products rendered. And for some reason, if you don't have any data available, that can just render blank. So you will not even come to know that there is a section called recommended components, because that context is right now different. It will not even render over there. Now with the components and the widgets, it becomes easier for you to build multiple pages which is required for you, whether you're in a PDP page or whether you go to a different style page or something. And there you can use these things. And in this particular case, it also gives you flexibility to use different text, I mean, different kind of rendering as well. The component is still same, but on the server side rendering, you can do it differently so that it helps you in search engine optimization over there. But if you are in a client side on a different page, you can still use the component in that page, and then you can also render. So the composition will actually, you can use it in different points. So yeah, the first one is the build time composition. You push it into a package registry, and each individual component is tested for all the different scenarios. So whether I have the data, what to render, whether I have an error, what to render. So the components are tested, the widgets business rules will be tested, and then when the application is there, you will build everything together, and then that will also be tested over there. So you will have tests written in different layers as well. So only one thing in the build time composition is the one who builds the app, there will be small dependency on that particular team. So you would have, maybe your team is working on the recommendation engine right now, you make some changes onto the that particular component, but you cannot use that in a PDP page at the moment, because maybe the one which is dependent on the PDP right now is not ready to release based on their changes. So in the build time decomposition, there is this one small dependency on the app which is using your component as a dependency. On the runtime composition, you can make sure the component is updated whenever there is a change. So one of the thing we try to do is you push a component, like you build and you push it into a registry. You have the asset somewhere, let's say S3 or somewhere also you can keep, or wherever, like you hosted your asset somewhere, and then you have some caching layer in front of that. So that caching layer, we will, I mean, on a typical basis, how we will build is you will have a main.sha.js, right? So the sha will equal, whenever you build, it will change. But we also try to add the version number over there. So let's say you're in a 1.6. So any version which changes over there, in your CDN or in your, let's say, S3 bucket or somewhere, you keep overriding the change over there. And then whichever the highest level of cache where you have control, you can also try to remove it from the cache over there. So if we have CloudFront or something, so you remove the file which is cached in the CloudFront, and then next time if somebody tries to hit that particular file, it will try to get the latest. So only if there is a breaking change or something, you change the version, and then you can have a dependency updated on the monolith application, which will try to take the, if it's taking 1.6, you can keep updating in the backend, like the new to 1.6.1, 2, 3, or whatever. But when it becomes 1.7, then your monolith should update into a newer version. It's also sometimes makes sense where if there is a change in contract or something, you will also have to make some change over there to use that. If you are registering for a callback function, you need to know, okay, if there is a change in data, or if you need the properties which you set somewhere in the file, sorry, in the global context, anything if you have to change, then that is a point you need to update your monolith, and you can reduce the number of releases where you're dependent on the old application over there. Then you can also do something like a composition. So from the browser, you will be going through a server, and from I mean it will never change, but on the reverse side, you will try to load different micro frontends from different servers over there. You can also structure your APIs such that anytime if it going through a particular route, it will always first hit the app server for you, and then internally it will route to a different. So there, once maybe you can go to a Next.js application and try to load something for a particular path. If it is more dynamic content over there, you can, or you can move to other application where the front ends are updated to a latest library, and you can load the assets from there. So you can use that kind of reverse composition as well. So this will have set of advantages compared to what you have as a monolith over there. So one is everything is individually built, tested over there. So whenever you make some changes, it's very easy to figure out your component is working fine or not. And then when you integrate in another application, so you know where it is actually breaking over there. And it's also not just about building, sorry. It's not just about building testing, even while building, right? So for example, how many of you would have already using Storybook or something where you visualize individual components over there. So having those things also, you can do it for all levels, whether it's at the application level, maybe, I mean, application level, maybe not, but the major component, you can actually have a Storybook with different parameters, how it renders. You can mock the data over there for different server response, how it will render. You can have different tests also, and also you can equally visualize quickly as soon as you're coding over there without actually starting your dependent servers. And also that's the design library in the reusable components. So that is one thing which is definitely there. Your application will scale at a pace which you will not even imagine once the features will start coming over there. So and every time you don't have to build again and again the same things. But the only problem with, actually I'll talk about the problem later. Yeah, the and yeah, applications will having its own release cycle is also really important. You will be really confident to push something on a Friday. Even if something goes wrong, it's very easy to just revert that particular portion. And also one advantage of compositions like this is the testing becomes very easier. Even if one particular component is screwed up right now, it will not crash the entire application. Only that rendering a recommended components is gone right now, or rendering some other review section is gone right now. So these are the small things which can get affected based on your breaking change over there, but your entire application can still be uh, like running properly. I mean, yeah, you never know, something can still happen. But um, the other thing is, in these kind of things, have a feature flag like the toggles, so that when you release, even though there is some dependent data which is missing right now, you can always try to have a feature flag and then disable that, push into the production, and then have turn on the feature once the everything is ready on the backend side as well. So you don't have to always worry about I'm dependent on something and I cannot push my front end code or something. The front end can still be released with the feature turned off, and then wait for something to be ready, and then you can actually turn it on. And then, yeah, the flexibility and also even the caching strategy is something we can decide at each of these different micro applications. So maybe the checkout, any assets related checkout, you don't need to cache over there, but some related to a PDP, maybe you can cache. And you can also decide individually what application should be cached at what level. Maybe some things you can cache for a longer time, one day also, if it doesn't change. Like once a product description has been added, you don't have to really change the product description. But some other content, if you need to say maybe 10 minutes is sufficient, you can decide on those things also. For example, the any translations related content. So let's say we saw interesting approach in the previous session. Maybe I should also explore that. But there are many people who also use something like making a API call to Contentful or something, where they fetch the translations directly from there. You get a bunch of data and then use that. So those things, if somebody updates from your content team sitting somewhere in other country, then if it's, they don't have to actually go and disable something if the caching is just 10 minutes or something. So okay, they updated something, and if it's not really mission critical, you don't have to worry about making that release immediate. After 10 minutes, it will fetch the new content and everything will be fine from there. So the advantages is there when you split it into different parts, and in each of them you can have the advantage to choose what you want in that particular application. The logging mechanism, I mean, these are a bunch of topics which you can do differently in each of them. Each teams can have a different release cycle over there. Then the shared state management, like I mean, you previously there was a time when there was a fight between one team was using Redux and one team was using Reflex or something, and somebody will come and say, no, I want a new tech stack today, and which is really cool, I want to know. So it's up to the team. You can leave the decision to the team, but this will come on the downside as well, where now you need to understand what is happening in different teams. I cannot just go and say, okay, I know what tech stack they have used and they have built right now, and I can quickly go and make some changes over there. So there's a interesting thing is, you need to arrive at a common ground, some rules over there, like, okay, these are the shared components. Who is going to make changes to the shared components? And it's somebody's responsibility to, whenever they touch, they make sure every library is properly updated. The changes they are doing is kind of uh, aligned with what is there as your designers have said over there. So all those things, like coming into a common ground, is the difficult part, the coordination. But a lot of flexibility will give you like, you can, I mean, it makes your life really easier to develop stuff on your day-to-day thing. The last point is something which you need to be really careful in this entire thing. So it's very easy when I say that you can take a component out of your monolith and then inject it from a new one, but there will be a lot of styles or something which is there in your legacy application which can override. You will never know what kind of event handlers which are already there and which you had never expected it to run, and it will start running at some particular point. So the main challenge in the injection part is to understand everything is going smoothly after you do that. If you are starting with a new application, you will have that freedom. You don't have to really worry about that because you have the entire control in your new application to start with something simpler and start adding on top of that. But you will never get you will hardly get freedom like that to start something new. You will always be like, okay, I don't want to lose out on the existing features, and you start replacing one at a time, and it will be always like that. Yep, that's it from my side for today.